Let's take a quick look at some of the challenges faced by developers who are tasked to deliver such an advanced user interface. An early decision to be made is whether or not another product's user interface can simply be adapted to meet the needs of the new project. If the requirements for the new project are too specific, the user interface team will be called upon to build a solution. Factors they will have to consider include the development language, for example Java or JavaScript, how the application will be deployed, will it be installed on each desktop or inside a browser, and the skill set of the existing development team. Do they know how to build a multi-layered map display, for example? No development team today would ever consider building the entire user interface from scratch. There is a wealth of reusable software out there. Let's refer to them as building blocks or components that have been designed to facilitate the assembly of many types of advanced user interfaces. Some of these are available in the form of open source projects, and some are commercially available from companies like IBM. Filtering through the options to meet these challenges is part of the job of the user interface development team. IBM offers a wide variety of products for building the types of displays we've seen in this presentation, including charts, maps, diagrams, time-based displays, and much more. These products are packaged as ready-to-use and ready-to-extend components, along with tailoring tools such as editors, and also with the underlying software development kits. In this way, the developers can quickly integrate new displays and at the same time, rest assured that the SDK will give them full access to the underlying parts. The IBM Visualization Products are available across a number of development and deployment platforms. The JViews family of products, for example, consists of 7 Java-based products, each tailored to a specific type of advanced user interface display. Likewise, there are offerings for Adobe Flex and Air, cross-platform C++, Ajax, and the .NET platforms. It's important to note that the various IBM visualization products do not have an identical feature set from platform to platform. The Flex charting displays are not identical to the Java-based displays, and this is mostly due to the differences in the underlying platform technologies. Let's go ahead and look at some demos of some typical applications. Here's a modeling application built with an IBM visualization product. We have a canvas in the center, and on the left we have a palette of different types of business process management objects. So I'm going to go ahead and start drawing some objects on the screen. I'm going to show how they might be connected. I'm creating a process flow diagram is what I'm doing. I'm going to go ahead and connect these up. Notice the nice visual feedback that you'd like to have when you're doing this kind of application. Okay, I've done a little time elapse here, and now I've got a little more of a diagram built up, but it's a mess, isn't it? It's not organized at all, and it's very difficult for a user to get information out of this. So what we're going to do is apply some graph layout technology to it. This will organize the diagram so that it's much more readable. I'm going to pick a type of layout that I want. Basically, I'm going to indicate I want it to flow from left to right. I hit the button, I tell it to lay out, and here we have the same diagram that I just created, but now everything's been automatically organized for me. So this was a very simple example. Here are some more sophisticated types of diagrams that can also be created. The second type of demo we'll look at here is another monitoring display. We have a heat map here that's synchronized with a scrolling table down at the bottom. The table has textual data that's indicating where users are using a particular application. Their locations are listed in the table and also on the map. As I move the cursor over the map, I can see the number of hits each country has produced. So China here has had 35 hits. I could also color the map so that a color is used to indicate the total number of hits: green, yellow, orange, or red. Green would indicate 0 to 25, and if you looked at the United States, it's just updated to yellow, which indicates that it now has more than 25 hits. This is a very nice way to get a good overview of what's happening and where. And this gauge down here below is also giving a number of hits per minute. And in this final application example, we have a data analysis display. We have information about the different countries in the world, and we're able to view them in order to try to understand the data better. We can see the data displayed on the map here, and the map is colored according to different criteria: population, population growth, or GDP per inhabitant, how rich a country is. We can see the US is quite rich, it's red, and Africa is in one of the poorer continents. We can drill down into a country, get more information that way, and see specific information for that country. Very nice panning and zooming effects make the application more appealing. So right now the map is colored according to GDP per inhabitant, and there's an alternate way of looking at the data. We can look at the same information in a tree map view. Here, the size of the boxes indicate the relative population of a country, whereas the color is showing how rich they are. So we see Africa has the poor countries, and Asia has the most populated countries. As mentioned before, user interface developers have a variety of open source and commercial choices. So why select one of the IBM products? IBM's visualization products have a long history of success. They originate from IBM's recent acquisition of iLog, a company that has specialized in reusable software components since 1987. The components developed then are no longer available, of course, but the latest generation of products still have the same goals that the original products had, to meet the most demanding needs in terms of both features and performance of mission-critical business applications. Specifically, the IBM iLog visualization components all share the following characteristics. They're all completely customizable. Everything about the look and feel of the interface can be controlled. They're designed to handle very large data sets, thousands of objects in a chart or a diagram, for example. And difficult problems such as arranging the elements and connections in a diagram into a readable workflow are provided out of the box. Naturally, all of these products are offered with technical support and, if needed, consulting. IBM offers these services on a worldwide basis. Let's summarize what we've covered. IBM iLog visualization products provide advanced graphical user interface components. These are used in a wide spectrum of mission-critical business applications. The products are available on a variety of development and deployment platforms and by display type. The benefits to using these products are twofold. First, they save time, at least 50% of the user interface effort, because developers can immediately leverage these pre-built, tested components. And second, they ensure that a top-notch user experience is delivered to the end user. We hope you have enjoyed this brief introduction to IBM's visualization product line, and we hope you come away with a better understanding of how these types of displays can help your software deliver information more effectively to its users. We encourage you to visit the IBM Visualization website, where you can watch other presentations, try one of the many interactive demos, and download a free, full-featured trial version of one of our products. Good luck with your development project, and thank you for listening.